بالنسبة للمياه غير التقليدية خلينا نحكي في المنطقة اللي بتعاني من شح المياه، خلينا نحكي في منطقتنا عموما، وبالإشارة لجيو 6 على مستوى المنطقة، خلينا نحكي غرب آسيا، اللي عقدت مجموعة من الاجتماعات وجميعها أوصت بأنه واحد من الحلول اللي بدنا نتعامل فيه مع شح المياه هو استخدام المياه غير التقليدية، باعتبارها هي أيضاً مصدر مياه، وممكن استخدامها بطريقة جيدة وممكن تكون بطريقة ممتازة ونستطيع فيها التعامل مع قضايا شح المياه. قبل ما نبدأ بحب أعرف بحالي، أنا الدكتورة مها حلالشة، أعمل حالياً بوكالة التعاون الألماني مع GIZ. الموضوع اليوم إن شاء الله يكون هو خلينا نحكي استمرار لمواضيع أخرى، ولكن موضوع حساس في المنطقة كليتها. بداية بحب أعرف على الدكتور إسماعيل الباز، وهو مايكروبيولوجيست، عمل في عدة أماكن، بدأ في الجمعية العلمية الملكية والآن هو يعمل في GIZ. هو مديري بالمناسبة، عمل مدير لعدد من المشاريع، آخرها مشروع الإدارة اللامركزية للمياه العادمة كإجراء للتعامل مع التغير المناخي، لتخفيف تأثيرات التغير المناخي. ورح يحدثنا اليوم إن شاء الله عن التحديات في موضوع المعالجة اللامركزية أو الإدارة اللامركزية للمياه العادمة في منطقة المتوسط في المينا ريجن، في منطقة المينا. فالدكتور إسماعيل باز تفضل، معك ربع ساعة إن شاء الله.
Yeah. Thank you, Dr. Okay, now it's on. Thank you very much for the nice presentation, ladies and gentlemen. Yes, my presentation today will deal with the challenges, as Dr. Maha mentioned, for wastewater treatment and reuse in the Mediterranean countries, and I am going to talk about a regional project funded by the German government and the European Union. The main, so the situation regarding the countries, the status quo of the partner countries, we work with them. We had several countries here in the region. In Jordan, these countries were Jordan, Egypt, Tunisia, and Morocco. And the main status of these partner countries was the water scarcity, which is the biggest problem these countries were facing regarding water and wastewater management. And the other aspect is the insufficient sanitation services in the rural areas, which was very interesting for us to look at these areas to support the services there, sanitation services there. And the other aspect was that these locations and these countries, there were insufficient and inefficient good governance in regards to water management and wastewater treatment and reuse. As I mentioned, the countries are Morocco, Egypt, Tunisia, and Jordan. The project was started in January 2012 and lasted until March 2016 with a budget of 4.3 million euros. The beneficiaries of these were the policy makers, decision makers in the water sector, but also at the same time the local communities and farmers who should benefit also from the activities of the project. The main objectives, as Dr. Maha mentioned in the presentation at the beginning, is to support the capacity of the partner countries in regards to the sustainable integrated management of non-conventional water resources. This capacity should be improved at the end or during the implementation of the project to use wastewater as a resource. And very important was to, what we wanted to achieve is to present good practices of integrated wastewater management in the different partner countries that can be upscaling later on to support the policies and the strategies of the counterpart in these countries. The 4 countries which, on the 4 locations which we have, you can see it here in this map. We started from the west to the east, from Morocco, our partner. In Morocco, we are working with the Water Basin Agency. It is one of the local authorities dealing with water resources management in the Kingdom of Morocco. And the location was at the South Atlas area. It's a small village, Ayyadi. And the focus of the project there and the pilot there was the eco-sanitation and rainwater management. And the second country was Tunisia. We worked with the National Sanitation Office, UNAS, who's responsible for, as most of you know, for the wastewater management, wastewater sanitation services in Tunisia. And the location was in South Tunisia, in Medellin, in Qalat al-Khudr. This is where their treatment plant is existing. We wanted to use the demonstration project there in this treatment plant. And the focus in Tunisia was the water quality monitoring and management, and also to support the good water governance at the end between the water provider and the farmer who's using the treated wastewater. The third location and country is Egypt, and there we were working with the holding company for water and wastewater, our counterpart from the GIZ. And the focus, the village was Al Juzaira. It is in the Ismailiyah governorate, and the focus was the decentralized wastewater treatment and reuse within this rural area in Egypt. And the fourth country is Jordan, and there we were working with 2 partners, Al-Balqa Applied University and IUCN, these 2 non-profit organization, but also under the umbrella of the Ministry of Water Irrigation as the counterpart of the GIZ in Jordan. The location is the Public Security Directorate near Amman. This is the police center for the civil police in Jordan. And we constructed there a treatment plant, decentralized wastewater treatment plant and reuse as part of the we call it peri-urban level or location in regards to Jordan. I will explain some information about the different locations, different treatment and pilot which we constructed, and the outcome of these different projects. And I will start also with Morocco. And in the village there, Ayyadi, which I mentioned in the South Atlas area. This village is a typical village for the rural areas. We have 1,000 inhabitants living in this area with very low education, as you can see here, 43% illiteracy there. Agriculture area, 31% of the land is used for agriculture area, and at the same time, the village is facing water shortages. It's very low precipitation of rainwater, and also problems with flood, but from time to time this occasional flood caused a lot of problem for the village there. The household income is very low. It's a very poor area, and the water consumption around 10 cubic meter per month, and drinking water is unreliable, unmonitored, and so the quality problems, there's a lot of quality problems there. And regarding the sanitation systems is very poor. Also, they are using soak pits, and so septic tanks can we say as the simplest way of discharging of wastewater. So this is the condition and the baseline which we started with in Morocco. The challenge in Morocco were, as I said, the occasional flood problems and the poor sanitation. It's both things was a big problem there. And the second one is the difficulties in serving the community still with sanitation due to the scattered distribution of the houses, and the topography itself caused different technical problems, and there were no any site available to construct centralized wastewater treatment plant. And due to the economic situation, the poor economic situation, the financial constraint were one of the issues this village is facing. The concept which we have done in Morocco was based on the eco-sanitation concept, which is one of the activities the GIZ is following in our partner countries. And just to see here the very simple diagram, what we mean with the eco-sanitation, to start separation, the nutrient from the beginning, from the source. And our intention was to avoid any contamination of the freshwater resources. And it doesn't make any sense to use freshwater resources to transport fecals and feces from the human or from animals. And this is the principle here is to do something against that, to start separation and reusing all the nutrients from the beginning to avoid any contamination of freshwater resources, to save freshwater resources, and to bring a maximum benefit and use of the nutrient which is available in the wastewater which we are producing. And this is a very simple diagram to explain what we mean with the eco-sanitation system which we applied in Morocco. So to bring a few information about the project itself and the outcome of the project. So we applied different treatment technologies there in regards to the sanitation management level. And these different technology were done in different places within the village itself. So we had methane digester, so an anaerobic treatment of the wastewater. We have an anaerobic baffled reactor to produce biogas. And this is what we call it urine diverting, dehydrating toilets, so toilets where we separate the urine from the feces, the solid feces, as a matter of separation of these different sources within the wastewater and within the sanitation aspect. And as I said, to avoid any contamination of the freshwater resources. So this is regarding the different technologies which we applied, and the outcome of that within this village. So the biogas was used for cooking and heating within the village itself. So a big improvement for them due to the economical situation which they are facing. And the digester, fertilizer which produced from the digester were used in the fields as fertilizer to support the agriculture activities. And also the excreta and urine which was produced were used also as nutrients. As you know, it's rich in phosphor, and phosphor is a very important nutrient element for agricultural activity. And this was used directly without any contamination to the water resources. The second aspect was what we did is the flood management level. So we also constructed the retaining wall for the village and support them during the heavy rain season to prevent any floods problem which the village was facing several times in the past. The other aspect is the capacity building and awareness raising. We did a lot of training programs, activities with our partner there for the villages, for the farmers, and for the stakeholders themselves to support the capacity building there. This is regarding Morocco. When it comes to Tunisia, we are now moving from, as I said, from west to east. In Tunisia, our location was in South Tunisia, in Medellin. And the project was located in an area with about 30 hectares of irrigated land, and the treated wastewater should use for this irrigation, which is normally used there to grow trees, forage, crops, and other agricultural activities. Also, the area facing water shortages, very low annual precipitation, around 157 millimeter per year. And we did the project in the Medellin Governorate in South Tunisia, very close to Jerba. And we constructed our treatment plant as tertiary treatment for one existing treatment plant in Qalat al-Khudr. I think our colleagues from Tunisia know that carefully. And this treatment plant was overloaded and received influent of 8,870 cubic meter per day. And the quality of the treated wastewater very bad. And therefore, the farmers were rejecting to reuse the treated wastewater. Only 16% of the effluent were used for irrigation purposes, and which forced the authority there to discharge this treated wastewater in this Wadi Smar, which is cause a lot of environmental problems and contamination in South Tunisia. And there was a conflict between the farmer and ONAS, the sanitation office, the National Sanitation Office of Tunisia, who is responsible for the wastewater treatment in Tunisia. And there were no trust between the farmer and the wastewater provider. And our approach was to support, to improve the quality of the treated wastewater and to support this relation between farmer and the government, and to invest in the good water governance, we can say at the end, in regards to our partner in Tunisia. So the challenge, as I said, was that the monitoring of the treated wastewater, there was no real monitoring system to assure that the water quality is within the standard and safe for using in agriculture activities. And the irrigation use, there were no practices to reuse treated wastewater, and so from that we wanted to support and to help our Tunisian partner. What we did in Tunisia, as I said, so upgrading this treatment plant, so we constructed a slow sand filter as tertiary treatment, and slow sand filter is well known as robust in regards to treatment to effluent load, and maybe the wastewater expert, I think, can confirm that. And especially using it at the end of a biological treatment unit produce better effluent quality, and this was the case. And at the end, the treated wastewater after this slow sand filtration was really the sampling and the analysis which we have carried out at that time was promising, and we had very low BOD level, around 8 milligram per liter. I don't have the result here, but I know that from our Tunisian partner, they were sending this lab analysis to us regularly. And also from the microbiological point of view, the wastewater were really very, very safe, as all of us know that slow sand filter is very efficient in regards to elimination of viruses, bacteria, and even also Ascaris eggs, which could cause health problems later when it comes to reuse practices for this treated wastewater. And the other thing which we did in Tunisia is the installation of a monitoring and early warning system, so based on SCADA system. And this system was, we installed an online multi-parameter analyzer, taking sampling regularly. And all these data and the result of these data were transferred to all stakeholders, the ONAS and also the other stakeholder in the region, the people who are dealing with the environmental protection, the Environment Agency, and the pharma organization, and all these received these results at the same time, and they were aware about the quality of this treated wastewater, which was important for us, that they see that this treated wastewater is safe and can be used for agriculture purposes without harming the people. And this was done. And based on that, we have to get approval from the Ministry of the Environment in Tunisia. So we conducted an environmental impact assessment study, and based on this environmental impact study, the Tunisian partner developed environmental management plan to support the follow-up of the impact of this treatment plant in terms of quality control, monitoring, and also improving the surrounding area from an environmental point of view. And last but least, we did also, like Morocco, a lot of capacity building programs, seminars, activities, which we conducted jointly with our Tunisian partner. To come to Egypt, so within the eastern part of the Mediterranean. So in Egypt, as I mentioned, we constructed our pilot plant in the Ismailiyah Governorate, Al Juzaira village, and here also similar situation like the other countries. We have water scarcity there, and very low annual precipitation, around 1,183 inhabitants, and the consumption of water is also very low, 50 liters per day, and also the same, there is no sanitation facilities there, only cesspits and open trenches where the wastewater, the raw wastewater were discharged, and no monitoring and no control for this discharge of the raw wastewater, and this causes a lot of pollution problem, serious environmental pollution problem for the village. And so the same intention here to improve the sanitation facility and to improve the quality of the wastewater and the health condition of the people in this village. The challenges here is the same as the other countries, the poor sanitation conditions and the environmental pollution which such sanitation is producing, and also the uncontrolled use of wastewater for supplementary irrigation. So the people that are taking the raw wastewater and use that for irrigation, and without monitoring what happened with such products, agricultural products which they are producing, and they're selling that in the market. So what we did in Al Juzaira, so the first thing was for us is to construct an innovative decentralized wastewater treatment system combined with sewer. So we did both because the village was not connected. So what we started with the decentralized wastewater treatment plant, which is a compact treatment plant, as a biological treatment with aeration and using all the steps of treatment, from denitrification, nitrification, and at the end also the removal of BOD. And now, so at the same time, so we did also capacity building for stakeholder and the local community. Now the sewer system is going to be connected, because at that time we didn't have enough fund from the EU to invest in the sewer system, but there was an agreement now signed between the GIZ and the holding company to connect the village now with this treatment plant. So around 50% of the village, the inhabitants will be connected. So the tendering, as I understood from Dr. Rifat, I think he is here, that is now running to construct the sewer system, and then the treatment plant can be operated by the holding company of Al Ismailiyah. Regarding Jordan, we did our pilot plant at the Public Security Directorate, the PSD compound, with around 2,466 people with, we have other annual precipitation here of around 400 millimeter. But the point here at the PSD that the PSD were using freshwater resources for landscaping, for the irrigation, the area, and we wanted to support that, to reduce using this freshwater resources, and to have a demonstration plan, the first one in a city as a decentralized treatment plant, as very close to the capital, to Amman city, which no sewer connection there. But what our intention is to demonstrate that this kind of decentralized treatment is possible, is feasible, even in a big city, and we can contribute also to save freshwater resources and to reuse the treated wastewater for this agriculture purposes. I will come later on to some comparison why this activity in Jordan were really feasible, also from economic point of view. When we can compare that with the investment cost which we have invested in this treatment plant. The same challenges we have here, the shortages in water supply in whole Jordan, as all of us know, and also the contamination, or the possible contamination of groundwater resources. There's overuse of groundwater resources in the whole kingdom, and therefore wastewater treatment reuse is